Before we end our topic on vectors, I just wanted to show you some applications. I know we've seen some of these in problems that we've done, but I always like to answer the question of, why do we have to learn this? So these are some applications of vectors that we haven't really gotten a chance to talk about. So we've done some problems already of using vectors in modeling with physics. So if you have an object on an inclined plane, gravity is acting straight down, and we want to know the force required to, maybe push this up the incline or keep it from falling. And so that's a kind of a classic application of vectors. Something else that we might see is the physics of falling objects. So if this guy drives his car off of a cliff, obviously it's going to follow this parabolic path. We already know that that's true for falling objects. We can take a vector at every moment and split it into the horizontal and vertical components of how this is falling, because we have forces acting on the horizontal direction. That's the speed that it's going. And notice the horizontal doesn't change. The only thing that's going to act on the horizontal component is wind resistance, which is pretty negligible at this. But then the vertical component, you'll notice, is getting bigger each time, and that's because gravity is acting on this car. Once it goes off the cliff, the gravity is causing it to fall down. So those are pretty classic examples of physics and vectors. We use vectors all the time with modeling things. So this maybe is something you've seen on a weather report, but it has, wind speeds. And so remember, vectors give magnitude and direction. So you can see somewhere here has a larger vector than maybe here. So the wind is stronger, and it gives us an idea of which direction the wind is blowing. Similarly, we can model the airflow. This is the cross section of a wing of an airplane. It's called the airfoil, and so because of the way the wing's designed, air flows faster over the top of the wing than on bottom. And if you remember your properties of gases, if it's moving faster, that's going to be less pressure on the bottom and more pressure on the top, which creates lift, and that's what helps an airplane stay in the air. And then this vector on the back is your drag, which of course always exists for airplanes as well. Another application would just be modeling the flow of gases. So think of this as like a chimney, maybe for a factory or something. And so the smoke or the gas comes out and how it behaves afterwards and dissipates into the atmosphere. We can model that with a vector field. And we can do the same thing with water. So if we have a river or a reservoir or even just your sink with a couple drains in it, we can model how the water flows, how it circles the drain, and that kind of thing for flows of water. We can also use vectors to model currents on a larger scale. So maybe the ocean currents, and a larger vector would mean a stronger current in one particular area. And then another application that we've talked about, hopefully you guys checked out the video last week, is search engines. So there are vector applications of that. Remember, finding the angle between two vectors, and that helps us know if a particular hit is a good fit in your search engine. So if you want to see more about that, check out the video from last week. And the last one that I want to talk about is artificial intelligence. This one's a little bit more complicated, but any data point, let's say we're talking about Marie Curie, we can associate all different vectors with her, just like facts, like where she was born and age and where she went to school and what she studied and all kinds of different things, gender. And if we do that for all concepts, all words, this creates this multi-dimensional snippet of her life. And so if you think of each fact as a different vector and beyond 3 dimensions, because we're talking about more than 3 things, we could be talking about, a dozen different things about her. The computer's not limited to 3D modeling like we are. And so what the computer does is it takes all of these words or ideas and has them in this multi-dimensional space. And then things that are close to each other, so using vectors, things that the angle between them is relatively small, it will start clustering those things together. So if this is just words, maybe this is a cluster of days of the week. the computer starts learning that they have similarities. And maybe this is a cluster of numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So based on all of these different dimensions, the computer starts learning about which words and which things have associations and things in common, and it starts learning about them. And this is all happening through vectors in multidimensional space. So anyway, obviously we're not doing all of that in this class. We are just learning the very basic foundations of vectors, and I just wanted you to see that it is widely applicable to all kinds of different sciences.